Today starts our introduction to a calculus topic called limits. And a limit is one of the essential building blocks in calculus. And what we'll do now is just kind of do a brief overview of what a limit is. So if we consider this function here, f of x equals x cubed minus 1 over x minus 1, and we have a graph right here, you can see that the graph is not defined at x equals 1. So here's x equals 1. And there's a hole in the graph, so it's undefined at x equals 1. But if we want to find, we want to find out is what does the graph do, or what is the behavior of the function as we get closer and closer to x equals 1. So to get that idea of what is happening, as we get closer and closer to x equals 1, we can create a table of x values that get closer to 1 from the left and from the right side. So we have this table right here, and you see as the x values start below 1, and we get closer and closer to x equals 1, the y values are getting closer and closer to 3. And if we look at the other side, okay, as the x values start at a number bigger than 1, and they get smaller and smaller and get closer and closer to 1, the y values also approach 3. So as you can see, the x values, as the x values get closer and closer to 1 from the left and right side, the closer the y values get to 3. So even though the function is not defined at x equals 1, because that gives us 0 in the denominator, so it's undefined, there is a limit as x approaches 1, and it's written as, we have right here, it reads as the limit as x approaches 1 of f of x is 3. And that is called limit notation. So we limit notation as x approaches some value, so that's the x value here, it approaches some number, which is a y value or y coordinate. So the limit does not depend on if the function is defined. The limit depends on which y value you are getting closer and closer to. So in example 1 here, we're going to use this table to find the limit as x approaches 2 of x squared minus 3x plus 2 over x minus 2. And then we're going to write that in limit notation. So we'll get out our calculator, and we're going to use the graph and trace feature. So here we're going to do x squared minus 3x plus 2 over x minus 2. So here's a picture of our graph. It looks like a line. And remember, when we press trace, we can type in x values. So I'm going to type in 1.75, and we get 0.75. Then we're going to type in 1.9. 1.9. And we get 0.9. Then we'll type in 1.99. And we get 0.99. Now we can't type in 2, as much as when I type in 2, there's no y value, it's undefined. So let's go on the other side, 2.25. That's 1.25. Then let's type in 2.1, and we get 1.1. And then finally we'll type in 2.01, and we get 1.01. So we can see that from the left side, the y values of the f of x values are below 1, and they get closer and closer to 1. And from the right side, or when the x values are bigger than 2, and we get closer to 2 by getting smaller and smaller, so we're going this way, our y values are getting closer and closer to 1 as well. So we would say that the limit as x approaches 2 of f of x is equal to 1. That's how you would write it. So we can find limits using different techniques. We use a numeric table above. That was one way. Another way is by looking at a graph. So we have this graph here, and even though f of x is undefined at this point, you can tell because there's a hole in the graph. So what that means is f of 0 is undefined. What y value does the graph get closer to from the left and from the right? And that y value gets closer and closer to, here's 1 to 2. So you would say that the limit as x approaches 0 of this function f of x is equal to 2. So we're going to focus more on the graphing aspect first. So on the next page, a limit can be evaluated from the left side or the right side of a specific x value. Those are called one-sided limits. So up here in our table, we looked at these functions from the left and from the right. Graphically, we're going to start by going just from one side. So here we have the limit as x approaches c, and this little plus sign right here, what that means, it means from the right side, or from the positive x values. Now, that doesn't mean that the x value itself is positive. It means that I'm going to be looking at it from the positive x values and approach closer and closer to whatever that c term is. So positive. I'm going to write this a little bit better. From positive x values. And then what we want to think of in words is what y value does a function approach as x approaches c from that right side. And then we also have limits from the left. So that negative from the left. So again, we're going to be from negative x values. And again, it doesn't matter if the actual x value is positive, negative. I'm going to be starting at the negative x values and get closer and closer to whatever it is. And again, what y value does the function approach? As x approaches c from that left side? So let's look at some graphs here. So we have the limit as x approaches -2, and then this positive sign right here, that means from the right. So here is x equals -2. Now if I start over here at positive x values and I trace the graph and I get closer and closer to -2, the x value -2, my y value is getting closer and closer to the x-axis, or 0. So that limit would be 0. Now we have here the limit of f of x, the limit of so in letter B, we have the limit as x approaches 0, And that negative side there means from the left, and that's not an exponent, that's just telling you which side to approach the limit from. So now let's look at our graph. Here is x equals 0, and if we're going from from the negative x values and we follow this graph, our y values get closer and closer to the number 2. Now here, the last one, the limit as x approaches 0, that positive means from the right. So starting at starting at positive x values, and I'm getting closer and closer to x equals 0 again. From this side, it also approaches 2, equals 2. Okay. So in example 2, we have the limit as x approaches 0 with that negative sign there, so that means from the left. So x equals 0 is right here. So we're going to start with these negative x values, and we're going to follow this graph. Now it jumps up here, follow the graph, jumps, and then the y value, we're not going to jump up here because we are saying what y value do we approach. So we're still on this line, and our x value is getting closer and closer to 0, but it's not going to equal 0. So the y value is approaching -1. Now letter B got the same thing, but from the right. So again, there's x equals 0, and we're going at it from the right side. Jump down, and the y value I'm getting closer and closer to is 0. Now, it doesn't matter that the y value is 0 when x is 0. It's what y value are we getting closer to? So it equals 0. So then our last example here, we have this weird looking graph, and then I'm going to have you try some on the next page. We have the limit as x approaches -2 from the left side. So here's x equals -2. And if I'm following my graph from the left side from negative x values, the y values are getting closer and closer to +4. So the limit would be 4. Now the limit as x approaches -2 from the positive x values. So now I'm going to start with positive x values and get closer and closer to x equals 2. The y value is again getting closer and closer to 4. Then the limit as x approaches 4 from the right side, so positive x values, here's x equals 4. So that y value is getting closer and closer to -2. And then the limit as x approaches 0 from the left side, so from negative x values, I'm going to trace the graph, and as my x values get closer and closer to 0, my y values are also getting closer and closer to 0. So 0. And then lastly, the limit as x approaches 0 from the right side, so follow this graph here, then it jumps. My x value is getting closer and closer to 0, and then my y values are also getting closer and closer to 0. All right, so I want you to try these on the next page, so pause the video, try them, and when you're done, unpause it, and we can see how you did. All right, so these are the answers you should have gotten. And I just want to go over them real quick. So the limit as x approaches -1, which is right here. From the left side, my y values are getting closer and closer to right here, where the y values are +1. And then coming from the right side, letter B, I'm getting closer and closer to 1 as well. The dot up here, the dot up there does not affect the limit. What this dot tells us is that f of -1 is equal to 4. That's what it tells us. It doesn't tell us what the limit is. And then the limit as x approaches +2 from the right side. So from the right side here, my x values, as I get closer and closer to +2, my y value gets closer and closer to -1. And then as x approaches 0 from the left side, my y values get closer and closer to +2. But the limit as x approaches 0 from the right side, I'm getting closer and closer to 0, that y value. And then the limit as x approaches 2 from the negative side, or the left side, my y values are getting closer and closer to -2. And then the limit as x approaches -2 from the right side, well, x equals -2 is right here. So from the right side, my y values are getting closer and closer to 0. So again, this idea of limits is what y value are you approaching as x gets infinitely closer to that number. It is not the same as what y value is a function when x is equal to that number. It's what y value do we approach as x approaches that number, that value. So thanks for watching this. Make sure to like it and subscribe.